Hello, network engineers. Welcome to the session 3 of the segment routing series. So in this session, we will complete our understanding on prefixed and sRGB. We will deep dive into some scenarios so that our concept will become more clear. So let's start. So scenario number 1 is explicit null. So in some scenario, we don't want to pop transport label. Instead, we want to retain it so that we can carry QA setting in the data plane. In order to do that, we will configure explicit null inside ISIS, loopback0 and prefix index. So I'll show you the configuration in lab router. Let's understand how it works. So as seen earlier, for PE4, we have configured index 4. So now PE4 will create own LSP with following entries. For 4.4.4.4, it will carry index 4. It will carry some flags. So in that flag, it will make P comma E as 1 comma 1. So once P3 will receive that LSP, it will calculate a local label, which would be 16,004. For outgoing label, it will check whether PE4 is directly connected to me or not. Since PE4 is directly connected via this link, it will check the flags. Now, if P comma E flags are 0 comma 0, which is by default value, it will put pop. If they are 1 comma 1 after configuring explicit null, it will put explicit null. So once traffic hit on P3 on this interface with transport label 16,004, it will match this entry, and instead of pop, it will retain it and send it to P4. P4 now will process transport label for MPLS setting and then VPNV for label and send the traffic to particular VRF. So this is my topology. Let's do the same in the lab. Okay, so let's see the configuration. So inside loopback0, here we will define explicit null. So before applying explicit null, let's see how database looks like. So by default, it is carrying P as 0 and E as 0. Now it will send this LSP to P3. It will send this LSP to P3 and P6. So let's open P3 and P6. Once P3 receives that LSP, it will calculate local label as 16,004 and outgoing label would be pop. SP, E flags are 0. Let's see the MPLS forwarding for label 16004. You can see on P3, outgoing label is pop. Let's validate the same on P6 as well. On 16004, the pop. On 16004 as well, outgoing label is pop. Okay, let's go to P4 and configure explicit null. Put it in the size look by 0, address only item for unicast, exit index, explicit null. Sure. So once I configure explicit null, now let's check the database. ISIS database P4 will post. Now P comma E flags are 1. So P3 upon receiving that LSP, now it will put explicit null in outgoing label. It will also put explicit null in outgoing label. Now, if we capture the traffic over here, or if traffic is coming from here, then we will see the P3 is retaining the transport label. So scenario 1 completed. So let's start scenario number 2. Prefix seed follows shortest path in segment routing. If a router receives LSP from multiple neighbor, the calculating router will install the prefix seed for the neighbor whose path to the root router is shorter. Okay, so let's understand this point in whiteboard. We will follow the same diagram with the same configuration. So we will concentrate on P2, calculation of prefix seed on P2. So let me write down P2 as a calculating router. Let's suppose each and every router has SRGB base as 16,000. So let's suppose P4 has created an LSP with 4.4.4.4 and index value 4. P2 will receive the same LSP from P3 as well as from P5. So now in M plus forwarding table, from which neighbor do you think P2 router will install the outgoing label? So is it from P5 or is it from P3? In order to know that, P2 will run SPF and will check which neighbor is shorter in order to reach root router. From P2 to reach root router, the cost is 20 here. In the upper path, the cost is 20. And on P2 to reach root router via P5, the total cost is 10, 20, 30. So since the upper neighbor P3 neighbor is shorter to reach P4, then P2 will install the outgoing label from P3. Next stop. So on P2, the LFE boundary would be local label would be 16,004. Outgoing label would be also 16,004. And next hop would be 23.3. So if we trace out from P1 to P4, it will follow upper path. So it will follow this path. So let's say I have made this cost as 100. Then in order to choose this one neighbor out of P3 and P5, again it will run SPF algorithm. So in order to reach P4, the upper path is 110 and the lower path, the path is 30. So 30 is smaller. Then in MPLS forwarding table, the next hop would be installed as 25.5. Okay. So this is what deadline means. If the router receives LSP from multiple neighbors, calculating router will install the prefix seed for the neighbor whose path to the root router is shorter. If the cost to reach the root router is same from the multiple neighbor, the router will install both next hop label from both neighbors. Okay, so let's say now cost here is 20. So from P2 perspective, the path to reach root router from the above one through via. So from P2, in order to reach root router via P3, the cost will become 10 plus 20, that is 30. And via P5, it is also 30. So the cost is same in order to reach P4 from calculating router. In that case, MPS forwarding table will install both next hop, that is 23.2 and 23.5, and will perform load balancing. For definition, so what is prefixed? So this is the label taken from the special memory called SRGB. So its instruction is to direct the traffic along the shortest route to the router that originates with. So let's compile the scenario 2 in the lab. So P2 is our calculating router and P4 is our root router. So if we check the route table for on P2 for P4, you will see the path will go via P3 and the total cost would be 20, 10 plus 10. So here the output of route table, the total cost is 20 and path is going via P3. That the last digit indicates the router number. Okay, and if we see the MPLS forwarding table, so in MPLS forwarding table, it will show the next hop as 23.0.0.3, which is R3, and install label for the same. Show MPLS forwarding table labels 16,004. So you can see next hop 23.3 is being installed. Now if I'll change the cost of link between P2 to P3 from 10 to, let's say, 100, then P2 will install the label from P5 as the path from P2 to P4. The shorter path would be via P5, that would be 30. So let me change the cost between P2 and P3 to 100. Router ISIS config P router ISIS core interface gig 0001 address family IP for unicast metric, let's say 100 for level 2. Root show commit exit. Okay, now if we see the root table, the shortest path would be via 25 and the total cost is 30, 10, 20, 30, and upper cost is 100 plus 10, 110. Okay, now if I see the forwarding table, MPLS forwarding table, I'll see the same next hop will be installed. The label via same next hop will be installed. Label 16,004. So now next hop is installed via 25.0.0.5. So the upper path cost is 110. The lower cost path is 30. So in order to make the equal cost, let me put 90 on P2. So 90 plus 10 plus 10, 110, 100 plus 10, 110. So P2 will install both next hop in the routing table as well as forwarding table. So let me put the cost between P2 and P5 as 90. And 50 router IFI score interface gig 02 and address family IP for unicast metric 90 level 2. Now if I see the root table, both parts should be installed. So as both of the metric, the upper path and the lower path, both metric is 110. And in the MPLS forwarding table, so both of the interface has been installed. Both of the next hop has been installed. Let's cover our last scenario, that is SR domain with different SRGB base. Let's consider P4 as a root router and P2 as a calculating router. Now let's make P2 sRGB base as 17,000 and keep all router sRGB base as a default one, which is 16,000. So let's see how prefixed calculation will happen when sRGB base is different. So like informed earlier, P4 will create own LSP with 4.4.4.4 and it will carry the index value as 4 and it will also carry SRGB base as 16,000. Now once P3 will receive this LSP, P3 will calculate local label. So local label would be 16,004 own SRGB base plus index value of root router plus uh, the outgoing label. Outgoing label would be pop here. So let's say P comma E flags are 0 comma 0 here. So outgoing label would be pop. Now P3 will send the LSP, P for LSP and on LSP to P2. Now P2 is having different SRGB base. So it will calculate local label as 17,004 on SRGB base plus index value of root router plus outgoing label index value plus SRGB base of neighbor router, which is 16,004. And same way P2 will send root router LSP to P1 and on LSP to P1. P1 will calculate local label as 16,004 on SRGB base plus index value of root router plus outgoing label as 17,004. So if we'll do a trace out would be like this. For the packet will hit on 12.2 with label 17,004. And then packet will hit on this interface 23.3 with label 16,004. And then packet will reach to destination, which is 34.4. 34.4 with an exclamatory with no label. So as you can see, if we use different sRGB base, the label uniformness will go. So label swap will happen with another sRGB label. So let's do this in the lab. So let me change the global block from 17,000 to 20,000. And let's quickly perform the calculation in the lab as well, laboratory as well. So first P4 orbits. You can see it is carrying E comma 0 P comma E flag as 0 comma 0 and index value 4. So it will send this LSP to P3. P3 will add the index value to the local sRGB base. So let's see the local sRGB base here, showing PLS label table detail. You can see sRGB base is 16,000, so it will calculate local label as 16,004 and outgoing label as pop because P4 is directly connecting and sending the P comma E flag as 0. So let's see the forwarding table. Labels from 16,004. So now P3 will send the P4 and on LSP to P2. P2 will calculate local label by adding on sRGB base to the index value. So let's see on sRGB base, label table detail. So on sRGB base is 17,000, so local label would be 17,004 and outgoing label would be neighbors sRGB base plus index value, which is 16,004. So MPLS forwarding table. Labels 17,004. So here you can see The in local level is 17,004 and outgoing level is 16,004. Any guesses, network engineer, why two labels or two next hop is inserted in the MPLS order forwarding table? This is happening because of the last lab where we have put uh, so where behind this there is one more network and we have put the same cost. That's why there are two labels here. Okay, now let's go to P1. P1 will calculate local label by adding its own SRGB base to the index value. Let's see. Let's validate the SRGB base by different command, which is show ISIS instance core. Here you can see SRGB allocated. Here it is the base value. So local label would be 16,004 and outgoing label would be neighbor's SRGB base plus index value. So neighbor SRGB base is 17,000. So outgoing label would be 17,004. So MPLS forwarding labels. Here I am putting local label. So local label would be 16,004. So when I'll do a trace route from P1 to P4, P1 will push 17,004, P2 will swap it with 16,004, P3 will pop it and send the traffic to P4. Let's do a trace route and validate. So 100, and here we go 17,004, 16,004 and pop. 17,004, 16,004 and pop. 12.2, 23.3 and 34.4. 12.2, 23.3 and 34.4. Okay, network engineers. With this, we have demystified sRGB and prefixed.